Okay, maybe sound. Oh, sounds like. Yeah, cool. Okay, let's start. So, off stream, I developed a version of function intervals which takes an interval of numbers from the problem 10 and finds necessary numbers, and also it doesn't only find necessary numbers, it splits into the intervals of unnecessary optional numbers. But I think it's really messy because you need to create this function add, and it's not at all obvious how to use it. What I want to do is to write this function using group by, and I believe it will be easier. So what we achieved right now is we have num required, which is list of pairs, and the first element of pair is the number itself, and the second is right. Yeah, the second was whether the number is optional or not. Wrap is adding true before and true after, because the first and the last numbers are required. In the problem, you can see in example that 0 and 52 are in parentheses because they are last and they are required. So that's why we put true at the beginning and at the end. And we are using group by on num required, and we are using equals on second element. So group by is by the function, and it groups equal elements together, and our equality here is that second element is the same. So what we will receive is a list of lists, and each element will be the list of numbers with the same second. So it will be first element will be all true, the second list will be all false, the third one the true, and the last one will be all the true. So the next step that we need to do is to take intervals with optional numbers and add surrounding numbers to that interval, and cut and remove all intervals with necessary numbers, because what we are looking for is the number of different combinations, and there is only one combinations to take necessary element. You can only take it. So the combinations arise only from optional elements that you have option not to include them, and therefore have different combination. Why do we include at the beginning and the end the required number? Is because we need to know, for example, in example here we have let's say 0 1 4 5 6 7. Okay, so 0 required, 1 is required, because if you remove 1 you will get from 0 to 4, which is more than 3. 4 is required, because if you remove 4 you get from 1 to 5, which is more than 3. 5 is optional, because if you remove 5 you will get 4 and 6, which is perfectly fine. 6 optional. 7 is required. So here we have in interval 5, 6 of optional numbers. But what we want is to expand this interval to include required numbers on the sides. It will be 4, 5, 6, 7. Why do we need this? Because we need, when we will iterate through combinations, we need to know what is the first required number to understand whether we can skip the second number. For example, if we decided we skip 5, can we still skip 6? And answer depends whether it's 4 or whether it's 3. Because if it's 4, we can skip 6 as well, and we will have 4, 7. But if it will be 3, we cannot skip because 7 minus 3 is 4, which is bigger than 3. So saying that, what we right now need to do, after group by, we will receive such intervals: 0, 1, 4, 5, 6, 7, 10, 11, 11, 12, 15, 16, 19. All of them are required. And what we want to transform it is to have interval of 4, 5, 6, 7, and also 15, 16, and 10, 11, 12, because these two intervals has options to choose and pick. So the way to do it is, I think, yes, I would be glad if we have function slice, which we can actually see in JavaScript. Do we have it or not? I believe if you have list, what you can do with it is slice 1 and okay, so there is no the step. In Python though we have step, right? If we, for example, have list, what we can do is to say it will be 0, 6 and 2, and we say yeah, we have step, so we take 1, 3, 5 because step is 2. I haven't found similar function in Haskell, so we will have to implement it. So what it takes is int let's say take n's. We have n, which is what number, which step is step, and we will have a list. What's hard about this function is that if you just implement it recursively as sort of like that, for like some element x and take n, it would be not ideal. We want to achieve here a tail recursion. So to have tail recursion, you will need to call the last invocation should be the function itself. So the last invocation should be like if something, then something, and else the invocation, because probably what we will do here is say that okay, so what we need here is also iterator to remember which element in current indices we will take in from. So what we will say we have take with n, but also we will have y and yeah, sounds good, and xs. Yeah, and this function will, if y equals n, let's say, actually good question. So what should be the start element? Should we take zeros element and then n element and then 2n, or should we take n's, n plus 1 element, then 2n plus 1? So basically, should we include the first element? I believe we should, because we always can set up. Yeah, it's easier to drop elements rather than append. So what we are saying, if we take n's, take the first element, then to use it, like if you want to tune this function from a list, and you have a list and you want to. So what I'm saying is, if we implement cutting of the first element, it will be simpler to use than if cutting the nth element. So I was saying then, if y is 0, then we will have to take. Oh, that's not looking great. Yeah, we also should have not excess but also result, and having a result is not a perfect solution, a result list, because why should we have result? So the issue is that we should store results somewhere. If we are gonna to use tail recursion, so we like say I plus 1 n, and put here some x, the element, and the tail of excess. The thing is, doing like this will result in the array being in the reversed order, and we don't want that, right? So to prevent this, we can do fold R. Because fold R starts with the n, so using columns will actually be really good. But the question now is, how do we know what element should? Oh, that's actually super easy. Forget tail recursions, such stuff. You don't need it. You just use zip. Zip. 0 to n with excess, actually just 0, right? Just 0 will give us yes, increasing by 1. Oh, actually yes, we can generate using step like this, 0, 3, and but doesn't matter. We cannot slice the list using test step, which is important. So here, and we just say take only those which when divided by n will equal 0. Simple. Actually, we need mod here. Yeah. So mod division by n will have, so the first element will be here. I think that's one more thing is that we are carrying only about second elements. And we are done. Why did we implement this function? Because we want to take only, for example, even groups, or also we want to act only odd groups. So yeah, I guess we will need to give this inter invals inters, I don't know. So what we now need to do is to zip3 okay, we don't need to zip3, yeah, zip3 vis if there is such function. Okay, we can zip3 vis, no we can do zip vis. So what we will do here is take ans2 from tail inters, because we want to skip the first one, which is necessary numbers. So this result in intervals with optional numbers. What we now want is to prepend the last element of interval before. So if you say take ans, let's say events is take ans2 events. Just to make it less spacious. So, and here we have events, but on inters. So this will include all necessary numbers. And we will want to do zip with prepend. Yes, but here we need an element, and element in this case is last. No, map last. Yeah, let's use operator. Yeah, but we also want to append the first of the next. So how we will do this? We need another zip. Yeah, I don't think that a great. Let's actually do zip3 and some function. And here we say last events drop 2 inters. Let's say drop 1 here just for generality. Yeah, so what we get here, also not last but head. Yeah, head. So basically these 3 arguments is before, current, next. And yes, when we have zip3 we want just to apply a function to every element, and we have here x, y, z. Let's say previous, current, next, and what we want here is previous current plus plus next. Should work, I think. Oh, events. Events again. Yeah, T is asking for that. Okay, one viewer. I guess that's by. Let's check whether chat is working with. Oh, to activate chats, please. That's interesting. So it might mean that there are some chat messages I haven't seen them just. Okay, doesn't seem chat having messages, but I also want to chat using Restream. How would we do this? To activate chat, please enable channels. But I've enabled all channels I have. Why wouldn't it connect the platform? Yeah, I did. So why chat is not working? Hi. Restream. Okay. Maybe I need to reopen it. Okay, I'll talking to me. Some made of. The chat is ready to display messages. So why can't I write to the chat?
I'm telling you, there is no exit. We're stuck here.
Yeah, hooray! Cool. Ha! Twitch doesn't see it because of internet error, but say is working nice. Cool. Yeah, I actually see. Superb. Okay. So what we are going to do right now? Oh, what we also can do is to okay. Group by? What? Yeah, of course. Group by is not a standard. It's not in the prelude. Wow. How many errors? 27. So what's wrong with this?
Would you please try to listen to me?
Zip 3 events interns. Okay, let's start with 39. Expected zip is applied to few arguments. 39. Zip. Oh, right. Okay, 39. Integer with int. In the second round, zip. Yeah, you have to. Right, because here you need to specify first, because that's what we're checking. Okay, in 29, fair 29. Drop to intern should be fine. second line of drop. Drop to intervals, right? Okay, so yeah, so we have int bool here. We say events, okay. Oh, right. So what we also want to do here is so we have combine. Okay, let's have function combine. Have nothing to prevent it. Combine, which is if you have previous, current, and next, we'll combine into one list. Sound nice. And here we will have so we want to choose the first, not the second. Yeah, first and combine. Parse error? Wow. What? Ah, right. So events, right? Drop 2 is fine. Events is fine. Ah, right. I'm dumb. Why would you need int here? Like it can be any number. That's interesting. 26. Okay, couldn't match int with int beyond. Expected type int bool, int bool, int bool, int b, int bool, int bool, int bool. Actual type int bool. And expected type. Ah, I see. I see. In the second combine. So expected that I will return a pair list, but okay. Yeah, right. So you need map of maps. So yeah, cool. Do we actually need? Yes, we need it. Okay, so we don't really need, so let me show. After group by, we don't need information whether it's necessary or not. We know for sure how the, so it will be map first. Yeah, and it actually compiled. So just to demonstrate what I'm looking for is, let's say we have here the example intervals 0, 1, 4, 5, 6, 7, 10, 11, 12, 15, 16, 19, 22. Perfect. So now is actually the hardest part of the problem, which is you found an independent interval of optional numbers. How many different arrangements can be done with it? So what I've come up with is that if you have an interval of 4, 5, 6, 7, what you can do is to say 4 is required. Okay, so what would be the next required, or rather how many numbers can I skip maximally? And here it would be 5 and 6. I can skip 2 numbers. sometimes it would be less than 2, because sometimes it would be just 5. Okay, so if it's just 5, like I either took 5 and skip 6, or either skip 5, took 6. Hard to say what follows. So useful use case to think about is just numbers from 1 to 10 without holes, like 1, 2, 3, 4, 5, 6, 7, and so on. And here we can choose just odd numbers or just even numbers. And in these cases you don't really have sort of interpolation or intersection between combinations, so you actually need to calculate both of them separately, I believe. Oh no, because there is interesting idea that no, I don't really know, and at this point I don't even know how to do it, so let's just iteration through all combinations, just trying everything we can. Which will take quite a long. Okay, let's actually use a bit of dynamic programming, please. Okay, so let's look at the case when we have 1, 2, 3, 4, 5, 6, 10. What would be the number of options? So we can start by saying that 10 is let's say 1, 2, 3, 4, 5. 5 is required. So what option do you have? You can pick 4 or not pick it, or pick 3, and those are both options. So if you pick 5, then it's the same as how many combinations. Okay, so basically on the number 5 till the end you have only 2 combinations, pick or not to pick 5. Then if you pick 5, then you can pick 4 or not pick 4. If you not pick 5, you must pick 4. Oh, sorry, 4, 3. No, you don't need to pick 4 because there is 2, so you can also skip 4. So basically what So whether to pick number or not pick impacts only in the case when you don't pick any numbers then, and you must pick. Hard problem indeed. Let's use Paint Online. No, let's not use it. Okay, what can we do? So what we can do is only reuse the stuff we already found. So we can say how many combinations we have after we choose what to do with for. Like for example, we say we chose for, how many combinations there? Or we don't choose for, how many combinations there? In the case of the for, it's 1, because you don't left with the numbers. You chose what you do for, you know you need to choose for. Okay. So question now, how many combinations is for if you choose 3? If you choose 3, you have 2 combinations. It's to choose for or not to choose for. If you don't pick 3, so it depends on the last picked number, right? Because if you don't choose 3, it depends on whether, okay, so if you don't choose 3, actually even should you choose 4 or not depends on the previous number. If it's 1 and you haven't picked up 2 and 3, you must pick up 4. But if it's 2 and you haven't chose 3, you can skip 4, because you can just take 5, and 2, 5 has distance of 3, which is good. 4, 5, 4, 3. So that's hard. You need to know. So your dynamic programming reused result should know of the last picked element rather than the choice being made. So what we say, for example, if the last picked animal a number is 4, then we have only one choice, because there is no options. If the last picked number is 3, then we have 2 options, is to pick for or not pick for. If the last chosen number is 2, then we have we can first option, not pick it anything, just go straight to 5. Or we can pick 3 and see how many choices there. Or we can pick 4 and see how many choices are there. And we already know that if we pick 3, it's 2 choices. But if we pick 4 instead, we have 1 choice. So it's the sum of them which results in 3 combinations, which sounds great. It really sounds like a good dynamic programming solution. So basically, generalizing. To find out how many combinations of if the last chosen element is n, then the number combinations that we can combine from elements of then is n plus 1 if we is the sum of the number of combinations if we choose n plus 1, the number of combinations if we choose n plus 2, and the number of combinations if we choose n plus 3. And if we choose both of them or 3 of them, this combination will be included only once. Yeah, only once, because if you say that I've chose n plus 2, that also means that you not choosing n plus 1. And this is unique combination, because if you say I choose n plus 1 and then you also choose n plus 2, yeah, it would be different combinations because the difference is the state of n plus 1. That's amazing. So one thing also to ask is whether we need to split into intervals at all. That stuff I just discovered is just simple formula. So what we have all required, right? So we say on 22 we have one combinations. Then on 19 means the sum of combinations of if we choose 20, if you choose 21, and if you choose 22. Okay, so what we're actually saying here is that only 22 is possible, so it's still one combination. So we don't need to split into intervals, even though it was interesting problem to solve with intervals and how to do this. We don't need it because solution is simple enough to not use it. And what we also want to do is to use map instead of, I mean, list would be fine because we have a step only maximum of 3. So list also fine. But at this point I believe map is simpler. Yeah, like we don't really we can also use array, but array will only store the boolean, which I don't think useful. So what we'll have, we have diffs void why we filter equals 3 diffs voltages zip with minus. Oh, I believe that's from the previous problem. So what we only need is joltages, 0 joltages. Do we want diffs? No, we don't need them. What we will have is just m from list. Actually s from list, set from list. Import data set as s qualified. Okay. Jolt map. Okay, so in this jolt map we say the maximum joltage. Actually we max jolt easy to find, and this is oh, we haven't sorted. Oh, I sorted. Why do you need then to sort? No good reason to sort. If we are using map, no good reason to sort. Yeah, so max jolt here would be maximum jolt map. Just making sure that there is a dataset maximum, and we're good to go. Oh, traversable, right? Maximum is traversable or something. Yeah, so that's wait. Why then max view? What I don't know what's max view, but I know I can set is foldable, right? Foldable, yeah. I just use maximum. Maximum to max jolt. Okay. So what we now say is a number of combinations, and we Actually, what we can do here is we can say maximal voltage. Oh, wait. Is maximal voltage is given, or should we find the one? Where is the maximal voltage? 22. Oh, maximal voltage is not given, so we will still need to find it, which is fine because okay, so yeah, we actually need map to store the number of combinations. It will be m from list, but what's interesting is that what we are going with do with the list of voltages. Yes, so 0 to voltages, just fine. Yeah, with this list we want to just include nothing. Wait, how would we do this? Okay, so yeah, let's say 0, just 0 to not to simplify. We of course can use nothing, but just to simplify, zip with 0. Oh wait, yeah, we need 0 0, I believe, because just 0 it will increase, right? Yes, so what we want 0 0 and no. Wait, yeah, that's exactly what we want. Yes, but what we also want to have is zipped is fine, but what we want is to have maximum voltages plus 3, and it will have one combination, but because we know for sure choosing the last element is one combination. Okay, so now we only need to get the number of combinations for all values down to 0. Easy, super easy. What we also want to have is only for actually nothing will be quite, or 0 combinations, fine, completely fine. No, okay, so what we want to do is we want to change the entry in the map only if it exists, right? If you have 0, yes, but if entry doesn't exist in the map, it means that we don't have such adapter, so we treat it as a 0. Yeah, sounds good. So we wouldn't assign the value, but we will treat it as a 0. Then jolt map, okay. I believe it will be the final result. We will go through maximum voltages minus 2. Yeah, max voltage is still useful. Max jolt minus 1 and then 0. I believe this syntax is working. Yeah. And what we are going to do with this is to filter. Yes. Okay, so we actually can sort. Okay, let's not sort, let's just filter. Member, right? So the function member checks whether the key is inside the map. But it's set. Yeah, let's use map. Yeah, member. That's true. So we filter by saying member. Member of Jolt map. Yeah. So we fill and we will have in the list only keys and we will evaluate only them. Okay, so we say filter. Yeah, but we also not want to have map, right? What we want to have is fold air. Oh, fold air. So if we will use fold air, we actually can trade through 0 to max jolt. And because it will start with max jolt, it just come naturally. But we also can use fold L, right? I believe in this case it doesn't make difference. Does it though? What we are going to do in fold L is to just evaluate, right? So we will just insert, right? Data map strict insert. What would be update? Interesting. Maybe. Oh, okay, I see. What if we say that? Okay, insert. Insert 4 6 from list 4 2. Yeah, would it rewrite from list? Yes, sure. We don't know. Data map strict from list. Insert. Yes, sure. Data map strict. Insert. Yes, it rewrites, which is perfect for me. Okay. So we just use insert in the result, and that's fine, right? What we will use is num combinations. Num comps. What will it do for us is it will have map. Let's use it as different num combinations, and we have map. But when we also have a number x which we want, basically what will return is another map. Let's say x with inserted value, of course, and the x, and the value will be who. That's actually sum, and yeah, map, and I will need map to just get. Okay, so there is in M. Can I use M? No. Data map strict. What we have is lookup with default, I believe, or get with default, something with default. Let's see. default. Find this default. Yes. That's actually what we are going to do. Find this default. And so default will be the first one here. Yeah, it will be 0. The key here will be the key. Actually, let's do it. Offset, I would say. Offset. Offset, and we are looking in the map M. Yes, and we finding the number of results. Yeah, so it's not sum. It's more like, yes, sum. You know, it's really hard here to think. So what we will have is to where yeah, so what we need to find the offset. So we will use map and then sum over, and then it will be find offset. This is not that hard, right? We just say map this function to what? That's it. It's not really. Yeah, let's just use this function to get numcoms. Okay, numcoms offset, and this is the function. Yeah. And then we can say map of numcoms to 1, 2, 3, and we have some of them, which is perfectly fine, I believe. No, not perfectly, because we don't consider sum as a function. We do okay, we are doing like this, and then it works just fine. Yes, sounds great. And after filter we say numcoms, right? Don't just del numcoms, right? Nothing to do here. Filter. Yeah, what we need is the first map is our actually jolt map. Yeah, numcoms. So numcoms doesn't look great in the sense that you have X and M. What is, so it's fold L, so accumulator is on the left, so it will be map X. So fold L, yeah, and we should get look up just fine, I believe. Oh, we have an operator for this. So we are taking 0, yes, and we just making print. Yeah, should work just fine. Just fine. Yeah, of course I need some. what's that? Right, because we need to specify that we want to have. Yeah, doesn't sound good, but it works, which is the most important. Main, of course. Example 4. Haha, is it true though? I believe it's not, but I appreciate them. From example, yes, of course it doesn't. But how did it go? Okay, so what we are seeing here is 22. Let's output the whole map. Yeah, for 1 second, let's say. Yeah, we don't have here. M to list and map M print. Why? Why this map contains only 2 elements? How is it possible? Right? Maybe because we are doing from list. How? Jolt map. Can we please just print jolt map and see that something is wrong? No, jolt map is only 0. Right, because I put zeros. And what should it be? Oh, right, because it should be the opposite, right? Keys are joltages and values are zeros. Number of combinations. Yeah, so here must yeah, exactly. Nice. By the way, jolt map is just fine. What we are seeing here, why don't we see any changes even though I just deleted the print? Oh, because it's empty map, something like this, right? No, it's actually this map. Okay, so it has zeros everywhere. How come? So member jolt map, right? Should filter. Oh, offset. Nice job. We need X plus offset here. Wow. X plus offset. Interesting. Let's print this map. It's empty, as we thought. So you say that max jolt -2, max jolt -1, 0. There are 0 members in the map. Wait, what does member mean? Is it for keys or is it for values? True. And 2, 4 will be false, right? Which is expected. So my assumption here is not wrong. What's wrong is what is max jolt then? Right, because it might think. Or yeah, because maximum here is joltages, maximum joltages. Max just plus 3. Max. Wait, that's really weird. Of course, I can print max joltage, but why? Why would be it useful? Jolt. Okay, I probably need to 19. Max joltage. Alright, because I'm dumb. It's not. It's plus, right? Okay, 8. Is 8 correct number? Yes, it is. So, okay, just uncomment. Wait. Why do we have? Yeah, because I haven't modified. Okay. 8. Nice. So what we need to do is to do a task. Actual task. The second example above, the one that starts with, let's see. We have task 1 example. Why do we have 2 examples? I don't know. Why there is no second in the large I don't know. Let's just add it and we will see how helpful it is. Example 2. Wait. It looks really good. Let us check. Yes, exactly. What is total number of distinct ways we can add that in your device, right? So we just need now to use real input and we will get. Let's see how it's. Yeah, perfect. That's actually an interesting task. And interesting how my solutions were evolving. Like I found first that you have independence between intervals. I implemented few alternatives for the intervals function, and then I found out that you actually don't need them, and implement a solution is like minimal amount of lines. That's really challenging. So what interesting function we used? Group by. Yeah, that was interesting. Yeah, there are two thoughts here. First, let's push. Okay. Yeah, and I will explain in comments interesting stuff I found. And that's one of the moments. What else have we had here? Yeah, I think that was the most valuable. Okay. All right. So discussions, right? Okay. What I want to have is GitHub code spaces. Can I have GitHub code spaces? That sounds amazing. Instead of programming in Bash on Windows, just using GitHub directly. Sounds good. Okay, I don't think I will go for the 11th. Let's just see what would be the problem. Actually, how many tasks do I have to solve? 17. I see 17. Okay. Today is 18th. Yeah. Okay, and I solved 10. So I have 7. That's quite a lot of them. Okay, I won't do it today, so I'm finishing for today.